Factor V Leiden is an inherited blood clotting disorder due to the mutation of one of the clotting factors in the blood called Factor V. This mutation can increase your chance of developing abnormal blood clots, also known as thrombophilia, typically in the veins. The coagulation system is controlled by several proteins, including a protein called activated protein C. Activated protein C normally inactivates coagulation factor V, which slows down the clotting process and prevents clots from growing too large. However, in people with factor V Leiden thrombophilia, coagulation factor V cannot be inactivated normally by activated protein C. While some people with the factor V Leiden disorder develop abnormal clots that lead to long-term health problems, most people do not.
So we'll go ahead and begin by talking about vascular spasms. And so this is what happens when you have a break in your artery. So basically what happens is like your artery will begin closing its diameter to decrease blood flow. So basically you don't bleed out. After the diameter of the arteries have decreased, you'll have this thing called platelet plug formation occur. And so basically what that does is these platelets will go into the break of the artery, and they'll kind of try to block any type of blood flow from going out. However, plasma can escape through that, and that'll lead us into our next step. This coagulation step is when that liquidy type of clot is going to then solidify and make it to where any type of plasma can no longer escape. Then comes the clot retraction phase. And so basically, this is going to be where like the normal flow of blood will wash out the clotting factors, basically you'll have a normal artery again. When that normal flow of blood occurs, it will inactivate clotting factors. It'll take a number of days, however, the clot will start to, deteriorate. It'll get smaller and smaller, and then soon enough, the walls of the blood vessel will begin to pull back together again. Basically, this is like the main repair phase. After the clot retraction phase, we have a process called fibrinolysis. During that time, there was a fibrin mesh. It removes that mesh. However, if it doesn't, it'll result in a scar.
As you can see, the red velvet cake mix represents the factor V and the water represents the activated protein C. The two cups on the right represent normal blood and blood with the factor V Leiden gene mutation, following damage to a blood vessel wall such as a laceration. Upon damage to a blood vessel, factor V is activated, which stimulates clotting. Here, factor V, the cake mix, is activated by thrombin and binds to platelets in both mutated blood and the normal blood. However, in blood that is mutated, factor V is resistant to cleavage by activated protein C, the anti-clotting protein. When activated protein C, the water, is added to normal blood, it cleaves factor V, which prevents further coagulation. Factor V continues to stimulate coagulation because of its resistance to cleavage by the anti-clotting protein, and abnormal blood clots can form.